Good morning students, welcome to Stay online classes. In the last class we discussed the last bit of theory part. On this today class I am going to discuss some of the numericals, that to NCERT numericals, and some of the questions in the last year they asked. I am going to discuss those numericals. Okay, before going to explain the numericals one by one, just see the brief glance on the complete theory of dual nature of matter and radiations. First, already we discussed about the kinetic energy point. What we discussed? The maximum kinetic energy, and work function. We discussed about this thing. What is the expression for maximum kinetic energy and work function means? That is half m velocity maximum square, which is equal to E V naught. Or we can also write like this also, half m v square maximum, which is equal to phi naught. This is our work function formula. Now come to the second one is Einstein's photoelectric effect. Einstein's photoelectric equation. Einstein's photoelectric equations, that is E, or we can say directly half m maximum whole square is equal to h nu minus phi naught. Or we can also say that half m velocity square h nu minus h nu naught. And these things we are going to use it in the numericals. Keep in your mind, these are the expression for Einstein photoelectric equation. And third one is in the Einstein equation only, the one more equation we should consider means work function and threshold frequency or threshold wavelength. If they asked in the numericals, find the threshold frequency with respect to work function means, we should write work function means, just to consider yourself, work function phi naught, or phi naught which is equal to h nu naught in terms of frequency, or in terms of wavelength means phi naught h nu naught. Nu naught means c by lambda naught. We know that already. Frequency nu is equal to c by lambda. Here is nu naught, that's why c by lambda naught. Why we are not considering c naught? Why? Because c is a velocity of light, that is constant values. Okay. Next is fourth one, energy of a photon. Energy of photon. This E is equal to h nu. Energy of photon is E is equal to h nu. And momentum of photon is momentum. We can consider the energy formula E is equal to mc square. This implies E is equal to mc into c. We can write c square c into c. This mass into velocity is nothing but a momentum. This we can write momentum into C. E is equal to PC. Or now P is our momentum. This implies E is equal to PC or P is equal to E by C. Momentum is equal to energy of a photon per unit velocity of light. And next we discussed the de Broglie wavelength, or if suppose we are considering how much photon is acting per second, means the number of photoelectrons emitted per second by source, number of photoelectron emitted per second by source, that we can also write, this we discussed in the first part bit, that is power by energy. Number of emission of electrons takes place. Just to consider, this is a sixth one, and these are the things we are using in the numericals. If they ask the maximum kinetic energy and work function relation, just use this relation. If suppose they ask in the question what is the photoelectric equation on the basis of the kinetic energy and frequency, just use this one. And threshold frequency or energy of photons, like this, if they ask, means we should use these are the expression. Now the very important is de Broglie wavelength. De Broglie wavelength of photon is lambda is equal to h by p, or de Broglie wavelength of any materials, de Broglie wavelength of any type of material, just they are considering in terms of momentum, that is h by mass into velocity. And we discussed about the de Broglie wavelength in terms of kinetic energy also, and de Broglie wavelength in terms of accelerating potential also. De Broglie wavelength in terms of kinetic energy, that is lambda is equal to h by under root of 2m ek. Ek is our kinetic energy. Now this is very important, de Broglie wavelength in terms of accelerating potential, that is lambda is equal to h by under root of 2m v into v. V is the potential and E is the charge of that particular electrons. If suppose they ask in terms of potential only, in the question they mention only potential, they not mention the remaining Planck constant values and mass of electrons. Just you remember yourself, this is the direct question. To solve this CET or NEET question, how to find the de Broglie wavelength directly by variation of potential, means just keep in your mind lambda is equal to 12.27 by under root of V angstrom. 12.27 by under root of V angstrom, or How we got this 12.27 means just substituting the mass of electron, that is 9.1 into 10 raised to minus 31 kg, and charge of an electron 1.6 into 10 raised to minus 19 coulomb. Just substitute the values, and this H we know that is Planck's constant, that is 6.625 into 10 raised to minus 34 joule second. Just substitute those values, ultimately we are getting the expression, that is lambda, which is equal to 12.27 by under root of V angstrom. Or we can also write 12 point or 1.27 or 227 under root of V nanometer. Just I am converting from angstrom to nanometer. These are the expression already we discussed in the theory bit. Just these expression keep in your mind. If you don't know these expression, it is not possible to solve the numericals. That's why once again I mention the expression in single slot. You just keep in your mind and go through the numericals. Otherwise it is difficult to solve the numericals. Okay, just keep in your mind all the expressions in your mind, and let us solve the first numerical on this dual nature of matter and radiation. Okay, let us solve the numericals. Many times they asked in 5 marks the theory as well as in the CET. The last year also they asked in Karnataka CET as well as in the NEET on this particular chapter. The NEET 1 questions, and also in the theory bit 1 question, 5 marks questions they may ask. Now come to the first question. Find the NCERT question. Find first numericals. Find the following. First one, the maximum frequency and the maximum frequency and the minimum wavelength of X-ray. Wavelength of X-rays produced by produced by 30 kilowatt 30 kilovolt electrons, produced by 30 kilo electrons in terms of volt electrons, given H is equal to 6.63 into 10 raised to minus 34 joule second. This is the question. This is the first NCERT question. Keep in your mind, they are going to ask, find the maximum frequency and the minimum wavelength of X-rays produced by 30 kilovolt electrons. As X-rays source produced 30 kilo means we can write like this, just to convert yourself. Voltage V, which is equal to 30 into 10 to the power 3. Kilo means 10 to the power of 3. Now we can write like this: 3 into 10 to the power 4 volt. This is our source voltage. These number of electrons produced by this much of photon energy. We should find the maximum frequency and minimum wavelength of those X-rays. Maximum frequency and minimum wavelength of those X-rays produced by this much of voltage. Now, what is the formula for maximum frequency? What is the formula for maximum frequency means? Just keep in your mind what are the things are given. One is the Planck's constant, that is 6.63 into 10 raised to minus 34 joule second, and another one is voltage. We know that according to particular frequency, if suppose we are considering the threshold frequency phi naught is equal to h nu naught. Just general frequency means phi which is equal to h nu. This phi is nothing but work function. That work function is nothing but, what is the definition for work function? Work function which is equal to charge into potential difference V. Charge into potential difference. This work function we can write phi naught. If suppose we are considering that much of energy is given, that much of energy utilized means work function, that much of energy given means h nu. This is our energy given. This much of work function, work is nothing but energy, h nu, which is equal to EV. We want frequency. Frequency means nu which is equal to EV by H. EV by H. Now substitute the values. What happens? Frequency nu which is equal to, this is the first bit we are going to solve. Frequency nu, this is the first A bit we are going to solve. This is the solution. First bit, frequency nu is equal to E. E means charge of an electron. Already we know that the values of charge of an electron, 1.6 into 10 raised to minus 19 into, what is the voltage? That is 3 into 10 to the power 4 volt divided by, what is Planck's constants? That is 6.63 into 10 raised to minus 34. Already they mentioned in the question. Listen here, this is in terms of joule and this is in terms of voltage in terms of V. Electron volt and joules, here is also joule seconds. If suppose we are considering in terms of electron, charge in terms of joules, and this is in terms of voltage, and this is joule second. Just it is going to cancel, joules get cancels, volt per second, or we can also cancel that voltage also, or this volts per second. It is the things are going to cancel. Why? Because this much of voltage is going to act. Now these are the things we not mentioned in the question. Why? Because we know that the SI unit of frequency is hertz or per second. 1 by second is nothing but a frequency, that is nu which is equal to, just solve yourself. The final answer is, that is 7.24 into 10 to the power 18 hertz. Very important is the unit of a particular maximum frequency is hertz. If you not mention the unit, means definitely you are going to lose the marks. Now come to the second one is the minimum wavelength of X-ray produced by this much of volt. The minimum wavelength means already we know that minimum wavelength, what is the relation now? H nu which is equal to EV. That is the energy H nu is equal to electron with respect to a particular voltage. Now shall we write like this Sc by lambda? This lambda is nothing but a minimum wavelength. If suppose we are considering frequency in terms of work function, that is H nu naught or H C by lambda naught. This lambda naught is our maximum wavelength. Now this is our minimum wavelength, above which there is no emission of electron, below which there is no emission of electrons. Now we can write E into V. Just to take this side, Sc by EV, which is equal to lambda minimum. Now the lambda minimum, which is equal to, just substitute the values. What is X? 6.63 into 10 raised to minus 34, and E is 1.6 into 10 raised to minus 19 coulomb. And now in terms of electron volt, electron means 1.6 into 10 raised to minus 19, or already we got the values of electron volt, directly substitute, or this is 3 into 10 to the power 4. Just calculate yourself. The final answer for that is 0.041 nanometer, or 0.041 into 10 raised to minus 9 meter, or we can also say that 0.041 nanometer. This is the final answer. Okay, this is the first question. Just keep in your mind what are the things we should remember, means what is the relation of maximum frequency. From the work function, this work is nothing but a energy. Energy equation is H nu. H nu is equal to EV. Nu is equal to EV by lambda. Now substitute the values. Ultimately we are getting the answers. Just keep in your mind the units are very important. If you not mention the unit, definitely you are going to lose 1 marks. Okay. Now similarly for second one also, the minimum wavelength, the same relation we should consider. This is the minimum wavelength. If suppose they ask maximum wavelength, means this is our maximum wavelength, phi naught, above which there is no emission of electrons takes place, below which only the emission of electrons takes place. That's why we are considering the minimum wavelength. Now come to the second question. Okay, the work function of cesium metal is 2.14 electron volt. When light of frequency 6 into 10 to the power of 14 hertz is incident on the metal surface, the photo emission of electrons occurs. What is the maximum kinetic energy of emitted electrons? And second one is stopping potential we should find, and third one maximum speed of emitted photoelectrons. These three we should find from the given values. What are the given? One is work function of a metallic substance, that is cesium work function, already I discussed. This is the lowest work function of a metal surface, that is 2.14 electron volt. The frequency also they mention, when light of suitable frequency is 6 into 10 to the power of 14 hertz. This much of frequency is incidenting on that cesium metal. The using this much of frequency, the emission of electrons takes place on that particular cesium metal. Then what is the maximum kinetic energy of emitted electrons, stopping potential, and maximum speed of emitted electrons? We should find. Okay, one by one we'll discuss. First you write yourself what are the given values in that question. What are the given values? Work function of cesium metal. Work function phi naught is equal to 2.14 electron volt. Then frequency, that is 6 into 10 to the power 14 hertz. We should find the maximum kinetic energy of emitted electrons. Okay, now first one, half m v max whole square is equal to, what is the formula? That is h nu minus phi naught. H nu minus phi naught. H is the Planck constant value. Already we know that the value of H in the last question, that is 6.63 into 10 raised to minus 34 joule second. Okay, the work function they mentioned and frequency also they mentioned. We know the value of Planck constant, that is 6.63 into 10 raised to minus 34 joule second. We should find this maximum kinetic energy. The kinetic energy max, which is equal to, what is H in value? That is 6.63 into 10 raised to minus 34. Joule second is the unit, and work function, that is 2.14 electron volt. It is not possible to subtract. Why? Because the units are different. One is joule second, another one is electron volt. Either you convert in terms of electron volt or you convert in the form of joules. If suppose we want to convert this to electron volt, what is the, once again you write here, what is new value? Frequency value, that is 6 into 10 to the power 14. 6 into 10 to the power of 14, and work function is, that is 2.14. Here joule second, here frequency is hertz, here is electron volts. These are the different units. This is also different units. That's why it is not possible to subtract directly. Either you convert in terms of electron volt or you convert in terms of joule. How to convert this in terms of electron volt means, you divide the charge value, you divide E, that is 6.63 into 10 raised to minus 34 into 6 into 10 to the power 14. What is charge value? That is 1.6 into 10 raised to minus 19. Now this is converted to electron volt. Now already this is in terms of electron volt only. And now the calculate these values, and power calculation you do first and multiply it and divide it. Ultimately our answer is, that is 0.345 electron volt. First you convert the powers, then you multiply, divide, and then subtract with 2.14. Our final answer or maximum kinetic energy is, that is 0.345 electron volt. Or some of the fractional calculation, it is going to vary, 3.6 also, 3.5 also. It's left to you. If you consider the fractional points, then it is going to vary the answer. But keep in your mind the whole, that is 0.3 is our answer for this particular first bit. That is, what is the maximum kinetic energy? That is 0.345 electron volt. Now come to the second one. What is second one? That is stopping potential. Half mv square, this velocity is the maximum, which is equal to ev naught. V naught is our stopping potential. Already we got the values of kinetic energy. ev naught is our stopping potential formula. Now just keep in your mind here, half mv square we are considering as maximum kinetic energy formula. That is ev naught. What is the maximum kinetic energy? Already we got in the first bit. That is, what is maximum kinetic energy formula? Answer is 0.345 electron volt, and this is ev naught. This e get cancels. Ultimately our stopping potential is 0.345 volt. This much of potential we required. Half mv square is nothing but a maximum kinetic energy. From the first bit we got the values, that is 0.345 electron volt, and half mv square is nothing but a ev naught, that is the stopping potential formula. Just substitute the maximum kinetic energy answer, and just to cancel electron, or you multiplies the values. Ultimately we are getting the stopping potential. Answer is 0.345. Next come to the last one, that is maximum speed of emitted electrons. Maximum speed of emitted electrons means, in terms of speed, just to consider yourself in terms of speed, how to convert. That is, in terms of speed, what is the kinetic energy? Maximum speed means half v max whole square. What is the answer for that? 0.345 electron volt. Now you want this v max. V max whole square keep here only, just to send that side. 2 is going to multiply here. 0.345 electron means 1.6 into 10 raised to minus 19 coulomb into volt. Charge into potential difference is nothing but a work or work function. Now into 2. Why? Because this half is going to multiply here. Here E value is 1.6 into 10 raised to minus 19 coulomb. Now divided is its mass, that is mass of an electron, that is 9.1 into 10 raised to minus 31 kg. Keep in your mind, mass of electron, which is equal to 9.1 into 10 raised to minus 31 kg. I substituted that values. Now just to consider yourself, this is V max. Just take the square, that side means square root of this values. Just to multiply yourself the square root of that values, and ultimate answer is 0.345 into that is 3.2 into 10 raised to minus 19 divided by 9.1 into 10 raised to minus 31 whole to the power 1 by 2 square root value. The final answer is, that is 3.488 meter per second. Velocity maximum is equal to 3.488 meter per second. This is the final answer for that. Okay. It is very easy to solve the numericals when you should remember the expression for particular given question. If you don't know the maximum kinetic energy formula, it is not possible to solve the question. And if you don't know the potential relations, it is not possible to solve. That's why before going to solve the numericals, you should remember yourself the formula or the expression for particular bit. Otherwise, it is very difficult to solve the numericals. Okay. Now come to the next question. The next is the work function for a certain metal certain metal is 4.2 electron volt. Will this metal give photoelectric emission? Will this metal give photoelectric emission? Will this metal gives the photoelectric emission for incident radiation of wavelength incident wavelength 330 nanometer given E is equal to 1.6 into 10 raised to minus 19 coulomb. Suppose they are not mentioned also, you should remember these values. And C is equal to 3 into 10 to the power 8 meter per second. And H value is 6.63 into 10 raised to minus 34 joule second. This is about the question. You should find, is this much of incident radiation is affecting that metallic surface. The metallic surface having a certain work function, that is 4.2 electron volts, and its frequency is 330 nanometer. This much of incident radiation is sufficient to eject the electron from this metal surface. Is it possible to eject the electron from that metallic surface? They are going to ask like these questions in the CET also. The work function of a metal is 4.2 electron volt and its incident radiation is 330 nanometer. This is the particular metallic surface. Incident radiation, this incident radiations in terms of how much its wavelength is? Its wavelength is 330 nanometer. 330 10 raised to minus 9 meter. This is the wavelength of incident radiations. That wavelength is affecting that metallic surface, or that wavelength of a incident radiation is sufficient to eject the electron from the metallic surface. You should find. Okay. Before going to find the energy, or before going to find the that particular incident radiations, we should keep in your mind what is the relation, what is the work function they mention. Solution in that given is work function phi naught, which is equal to how much? 4.2 electron volt. We know that already work function is nothing but a minimum or the maximum energy is given to that metallic surface, that is the minimum energy is given to that metallic surface, that is nothing but a energy. This much of energy is the energy is equal to work function, means then only the emission of electrons takes place. Then what is the unit of energy? Joule or electron volt we can consider. But here they mentioned in terms of meter, that's why we should convert the work function in terms of joule. How to convert? The work function phi naught, which is equal to 4.2 into what is E value, that is 1.6 into 10 raised to minus 19. Now we are converting in terms of joule. We are converting in terms of joule. What is the final answer means? That is 6.50, which is equal to 6.72 into 10 raised to minus 19 joule. Just to calculate yourself by multiplying 4.2 into 1.6, that is 6.72 into 10 raised to minus 19 joule. Now we know that the relation E is equal to h nu. This is Einstein photoelectric equation, that is E is equal to h nu. Nu is our frequency of incident radiations. We know that nu is equal to C by lambda. Why I am converting in terms of lambda? Because they mention the incident radiation wavelength, not frequency. That's why we should convert in terms of lambda. Just substitute here. E is equal to hc by lambda. hc by lambda. Now we know that the value of Planck constant, and also we know the value of c, that is velocity of light, and we know the wavelength of incident radiation. Now substitute the values. This energy is equal to this much, then only the emission will take place. Otherwise, if the energy is less than this work function, definitely there is no emission of electrons takes place. If the energy is more than this, then also it is possible to eject the electrons. If the energy is less than this, definitely it is not possible to emit the electron from that particular metal. Now substitute the values. H is equal to 6.63 into 10 raised to minus 34 into C value is 3 into 10 to the power 8, and H value is 330 into 10 raised to minus 9 nanometer. Now this is will come to the numerator, means plus 8 plus 9. This is around 6.63 into 10 raised to minus 34 into 3 1 ja. This keep as it is. Now this will come to the numerator, means plus 8 plus 9 means that is 10 to the power 17 divided by 110. You divide 6.63 by 110 and powers are same, the bases are same, power should be at minus 34 plus 17, 17 to the 34, that is nothing but 10 to the power minus 17, and divide it. Our answer is around 0.06018, and the final answer is for, after converting the powers, that is 6.018 into 10 raised to minus 19 joule. This is the energy given to that metallic surface. Is this energy is greater than this work function? No. Definitely it is not possible to eject the electron from that metallic surface. We require this much of energy. But from the given incident radiation, what is the energy? 6.018. Its energy is 6.72. Even small variation of energy will emit the electrons. This is the difference of energy. That's why it is not possible to eject the electron from the metallic surface. That's why it is not possible to eject the electrons. Just to write the conclusion point. Will this metal give the photoelectric emission? No. Why? The metals give the photoelectric emission? No. Why? Because the energy of photon is less than the work function. Our concept is, if the energy of photon is equal to work function or more than the work function, then only the emission will take place. Otherwise it is not possible to eject the electron from the metallic surface. That's why it is not possible to eject from the metallic surface. This is the one of the very important question. Keep in your mind, if you want to eject the electron from the metallic surface, that energy must be equal to work function or greater than the work function. Otherwise it is not possible to eject the electron from the metallic surface.